Welcome again to this presentation. Now we are going to start on question number 6. Last time we ended the question number 5b. Today we start on question number 6. Question number 6 is saying the vapor pressure of pure benzene, that means the vapor pressure of the pure solvent, is this one 640 millimeter mercury. A non-volatile solid of mass 2.175 times 10 power negative 3 kilogram is added to 39 times 10 power negative 3 kilogram of benzene. That means here we have the mass of the solid, and you also have the mass of the benzene, which is the pure solvent. The vapor pressure of the solution is this one. We have the vapor pressure of the solution, which is 600 millimeter mercury. They are asking what is the molar mass of the solid. Consider the solution as very dilute solution. That means for very dilute solution, we need to use the formula we have derived. Remember, in question 5b, we have derived the formula to calculate the molar mass of the solid when the moles of solid are negligible as compared to the mole of the solvent. Let's see the answer. What do we have? We have the vapor pressure of the pure solvent, which is P naught, is equal to 640 millimeter mercury. We have also the molar mass. We have the mass of the solvent, the mass of the solvent, which is at 9 times 10 power negative 3. We have also the mass of the solid, which is 2.175 times 10 power negative 3 kilogram. We have the vapor pressure of the solution, which is 600 millimeter mercury. Now they are asking to calculate the molar mass of the solid. We need to use the formula. This is the formula that we have derived in the previous question, question 5b. We can replace all the values. The P naught, we have it. This is 604 millimeter mercury. We have the MB, which is the mass of the solid. We have it here. We have also the molar mass of the solvent. The molar mass of the solvent, what is the solvent is benzene. That means we use the molar mass of the benzene. Then we have also the P naught minus P. P naught is the vapor pressure of the pure solvent. We have it. It's here. P is the vapor pressure of the solution. We have it. And here we have the mass of the solvent. We have it. Let's replace the values. We have the molar mass of the solid, which is equal to this one times this one. This is the P naught, the vapor pressure of the pure solvent. This is the MB, which is the mass of the solid. The mass of the solid was given as 2.175 times 10 power negative 3 kilogram. This is the molar mass of the solvent. The solvent is the pure benzene, and this is the molar mass of the pure benzene. We divide with the change in the vapor pressures, which is the vapor pressure of the pure solvent, 640, minus the vapor pressure of the solution. Then in this case, we need to multiply the MA, which is the mass of the solvent. The mass of the solvent was given as 39 times 10 power negative 3 kilogram. Then we do the other remaining one is to do the calculation, and we get the molar mass of the solid, which is equal to 69.7 gram per mole, which will be the molar mass of this non-volatile solid. Let's go to question 7. Question 7 is saying in experiment 8.04 gram of mannitol were dissolved in 100 gram of water. That means this is the mass of the solid and this is the mass of pure solvent, which is water. The vapor pressure of water was lowered by 0.309 millimeter mercury. That means here we have the difference in vapor pressures because it was lowered by. Then from 17.535 millimeter mercury, that means this was the vapor pressure of the pure solvent. Then they're asking calculate the molar mass of the mannitol. Consider the mole of solute as negligible compared to the moles of the solvent. Here also we'll use the formula because the moles of solute are negligible. The moles of solute are negligible as compared to the moles of solvent. What do we have? We have MB, which is the mass of mannitol, the mass of the solute. We have also the MA, which is the mass of the water, which is the mass of the pure solvent, which is equal to 100 grams. We have also the change in pressures. This means the vapor pressure lowering. So we have the change in vapor pressures, which is equal to the vapor pressure of the pure solvent minus the vapor pressure of the solution. We have also the P naught, which is the vapor pressure of the pure solvent. We have also the molar mass of the water. The molar mass of the pure solvent is 18 grams per mole. Then using the formula, we can just calculate the vapor, we can calculate the molar mass of the solid. Just use the formula and replace the value. Here we have the P naught. Here we have the mass of the solid. It was given, which is 18.04 grams of mannitol. We have also the molar mass of the water, which is the molar mass of the pure solvent. We have the delta P, which is the change in vapor pressures times Z. This is the mass of the MA, which is the mass of the pure solvent it was given, and then we get around 184.27 grams per mole as the molar mass of the mannitol or the molar mass of the solid. Let's go to question number 8. Question number 8 is saying we have a very dilute solution. That means the solution is diluted. That means the moles of solid are negligible as compared to the moles of the solvent. A very dilute solution is prepared from 26.2 times 10 power negative 3 kilogram of unknown substance. The substance is unknown, but the mass of the substance is this one, 26.2 times 10 power negative 3 kilogram, and 112 times 10 power negative 3 kilogram of acetone at this temperature. That means acetone is the pure solvent. We have now the mass of the pure solvent and the mass of the solid. The vapor pressure of the pure acetone is 0.526 atmosphere. So we have now the vapor pressure of the pure solvent. They are asking to calculate the vapor pressure of the solution if the molar mass of the substance is this one. Here, now the molar mass of the substance was given. Then they are asking to calculate the vapor pressure of the solution. Again, we are going to use the formula. So what do we have? We have the mass B, MB, which is the mass of the solid. We have also the MA, which is the mass of the pure solvent, which is acetone. We have also the vapor pressure of the pure solvent, which is equal to 0.526 atmosphere. We have also the MMB, which is the molar mass of the solid. In this case, it was given. We have also the molar mass of A, or the molar mass of the pure solvent. In this case, we are going to consider the molar mass of the acetone. Then we can calculate the molar mass of acetone, and we get 58 times 10 power negative 3 kilogram per mole. Then you can use the formula for the molar mass of the solid, which is equal to this one. Now they are asking this P, which is the vapor pressure of the solution. The remaining element you have them, then we can replace the values to get the vapor pressure of the solution. This is the MMB, which is the molar mass of the solid. The molar mass of the solid, which is this one, it was given, is equal to this P naught. This is the vapor pressure of the pure solvent. This is the MB, which is the mass of the solid. Then this is the molar mass of the MMA, which is the molar mass of the solvent. What is the solvent that was used? That is acetone. The molar mass of acetone. Of course, we have converted the molar mass to kilogram per mole. So that because here also we have the molar mass of the the solute in kilogram per mole. Here we have converted the molar mass of the acetone in kilogram per mole. We have also here P naught, which is the vapor pressure of the pure solvent. So this is what we have to determine, the vapor pressure of the solution, and this is the mass of the pure solvent, which is the mass of acetone, and it was given. So we can do the calculation. The remaining one are the calculation and the rearrangement of the terms. Then after rearranging different terms so that to look for P, we can find out that P, the vapor pressure of the solution, will be equal to 0.5 atmosphere. So you can do your calculation and see whether you are getting the same answer. Let's move to question 9. Question 9 is saying the vapor pressure of water at 20 degrees Celsius is this one, 17 millimeter mercury. That means the vapor pressure of the pure water. We have the vapor pressure of the pure solvent. Calculate the vapor pressure of solution containing 2.8 grams of urea. That means here we are having the mass of the solid in 50 grams of water. So we have also the mass of the pure solvent, which is 50 grams of water. The molar mass of urea was given as 60 grams per mole. Then they're asking to consider the moles of solid as negligible compared to the moles of water. And that means we are going to use the formula. Here we have P naught, which is the vapor pressure of the pure solvent, the vapor pressure of the water. We have also the molar mass of the water. So we know the molar mass of the water is 18 grams per mole. Of course, when you are counting 18, we are taking 16 molar mass for oxygen plus 2 for hydrogen, because the water is having 2 atoms of hydrogen and 1 atom of oxygen. We have also the mass of the solid, which is 2.8 grams of urea. We have here the mass of the water, which is the mass of the solvent. It was given. Here we have also the molar mass of the solid that was given. That means the molar mass of urea. It was given as 60 grams per mole. Then you will use this formula so that we can calculate the vapor pressure of solution. So because that's what they are saying, they are saying calculate the vapor pressure of solution. So we can replace the values. It's very simple here. We use the formula here. We have it 6 grams per mole, and then here we have it P naught, which is the 17 millimeter mercury. We have the mass of the urea. We have also the molar mass of the water. Here we have then P. Then we do also the arrangement to calculate so that we can get the P, which is the vapor pressure of the solution. Then after doing the calculation, we will get 16.72 millimeter mercury as the vapor pressure of the solution. So let's move to question number 10. Question number 10 is saying a 0.8 times 10 negative 2 kilogram of oxalic acid, that means the solid was dissolved in 700 centimeter cube of water at 300 Kelvin. So here, rather than giving the mass of the solvent, we have the mass of we have the volume of the solvent. We don't have the mass, but you have the volume of the solvent. The solvent is pure water, and the volume was given as 700 centimeter cube. Then they're asking to find the vapor pressure of the resulting solution if the vapor pressure of water is this one. So the vapor pressure of the pure water was given as 1.2 times 10 power 4 Pascal. And the molecular mass of oxalic acid is 126 grams per mole. That means you have the molecular mass, the molar mass of the solid. The density of water was given as 1 gram per centimeter cube. Then they are asking consider the moles of solid as negligible as compared to the mole of solvent. What do we have? So here we have the mass of the solid, which is 0.8 times 10 power negative 2 kilogram. The solid is oxalic acid. So what do we have again? We have also the volume of the solvent, which is 700 centimeter cube, the volume of water. What do we have again? We have also the P naught, which is the vapor pressure of the pure solvent, which is the vapor pressure of the water, which is equal to 1.2 times 10 power 4 Pascal. We have also the molar mass of oxalic acid, which is the molar mass of the solid, MB. We have also the, of course, we have the molar mass of the water, which is 18 gram per mole. Here it's not 18 mole, it is 18 gram per mole, because the molar mass is expressed in gram per mole. So then you can use the formula. We have density of water also, which is equal to 1 gram per centimeter cube. So from the density, we can determine the mass. From the density, you can determine the mass of the solvent. We have a mass of the solvent as 1 gram per centimeter cube. We can multiply with the volume of the solvent. That means we get 700 gram. If you convert it to kilogram, then you get 0.7 kilogram. So that means 1 times 700, then you get 700 gram. So we convert it to a kilogram by dividing with 1000, then you get 0.7 kilogram. After getting the mass of the solvent, then you can use the formula to determine the vapor pressure of the solvent. The vapor pressure of the solution. Because the vapor pressure of the solvent, you have it as the P naught, 1.2 times 10 power 4 Pascal. So we need to determine this P, the vapor pressure of the solution. Let's replace the values and see the answer. Here we are replacing the value. This is the molar mass of the solid, MB, which is 0.126 kilogram per mole. We are converting to kilogram. Here also we have the P naught in Pascal, 1.2 times 10 power 4 Pascal. We have the mass of the solid, which is equal to 0.8 times 10 power negative 2 kilogram, the mass of oxalic acid, and we have the molar mass of the water, which we have converted to a kilogram per mole. It is 18 gram per mole. You have converted to kilogram per mole. Here it is not mole, it is gram per mole. So converting to kilogram per mole divided with 1,000. Then dividing with, this is the P naught, this is the P, which is the vapor pressure of the solution that we need to determine. Then times 0.7 kilogram, which is the mass of the water or the mass of the pure solvent. If we continue to rearrange the terms, then we can get our answer. That is, you can calculate the different rearrangement, mathematical rearrangement, so that you can get the answer. You will get the vapor pressure of the solution, which is equal to 11.98 kilopascal.